Hi guys, so we are continuing with our look at the paper that was written by Bunoyo and Ebiwarame and Okrina. They wrote on mathematical modeling of alcohol drug concentration in the bloodstream. I like this paper because it gives a clear indication that mathematics is actually powerful in every aspect of our lives. So, without saying much, people drink alcohol. Let me not say beer. Let me just say people drink alcohol. They drink alcohol by drinking beer, by drinking some tequila, or you drink some strong stuff, whichever strong stuff you take with alcohol content in it. That's when we're saying, look, let's look at how the alcohol drug concentration in the bloodstream can be modeled using mathematics. So to get started, we are going to see now that uh, first of all, let's just have a brief look at their introduction because it's very important to look at people's introductions, and we're not going to dwell much on it. I'm just going to mark on a few things. Look at their introduction. Suppose you want to write your own paper, look at their introduction that they give a background to what happened. So blood is a body fluid in the circulatory system of humans and other vertebrates that transport metabolic what. Okay, so blood in the circulatory system is also known as peripheral blood. Yes, which is good. And then they talk about the blood up to this whole point. Now they talk about the percentage of alcohol, the ethyl alcohol or ethanol in a person's blood is what we know as the BAC that we were talking about yesterday, blood alcohol concentration. So this work was done by many authors. Obviously, from this introduction, there is no justification that is very clear. Okay, so the justification why this study is important is not very much so clarified. They went on to literature review, um, but they didn't specify why this study is actually important. So that is one of the things that you might look for in this paper and fail to find because that's what I'm not finding here. So they did a lot of review on some past literature, how people were using different methods, the sensitivity of the model. Some people use social media addiction. They talked about a lot of things, all right? But one of the things I'll point towards is how their work is going to be different or it is going to contribute to the board of knowledge. So they say that so they're still talking about what the other people did in they say however in his research, so this is the research of the other people that actually did some research. um so again, you see that this introduction is actually poor. I can say this is a poor introduction. All right. If I am to rate this introduction, I'll say it's a poor introduction because we don't know what was done by the other people, right? What was done by others. And also, I mean, not what was done by others, but rather what was done by as new to the board of knowledge, right? To the board of knowledge, because all they did was the literature review, what other people did. And the motivation, the justification, why do we need this study? So the motivation for this study was not explicitly said here in this particular work. So that is one of those things that we state because the introduction, remember, is what brings me into the paper to say, look, I think I want to read this paper. Now, they then, when they were talking about their methodology, the materials and method, that's when they say, look, this research is a theoretical study that involves the representation of alcohol concentration in the body and bloodstream compartments using mathematical models. Proffering exact analytical solutions and Laplace method where the pertinent parameters are varied for the purpose of studying their importance to alcohol concentration. So again, they didn't clarify why their study is important, is needed. What they are saying is that the maybe the new thing that they are going to introduce is a methodology. So yes, they are going to use the Laplace method and also simulate in Wolfram Mathematica, but we expect maybe more or less of the same results from with that compared to the work that was done by the others. I think that in terms of writing, this paper was not, at least up to this point, I can say that it was not properly written. Okay, now they gave some model assumptions here that go together with their model. So they want to go ahead and formulate their mathematical model. And they are saying the alcohol drug diffused from the body compartment to the bloodstream and compartment and vice versa. So there is diffusion that takes place from the body compartment to the bloodstream, from the bloodstream to the body compartment. And there could be an influence of the intercompartmental distribution rate constants on alcohol drug diffusion in the bloodstream. And there could be an influence of the excretion of alcohol drug on its presence in the bloodstream. Okay, and the change in the volumetric and dosage could influence the alcohol drug concentration in the bloodstream. So these are the assumptions that they made, which I think are important when you're talking in terms of alcohol concentration in the body. So they are just outlining these, and let's see. I think in order for us to understand what is going on here, let's talk about this guy that I found on the website by Santin. It was a website by people that are called Sandstone Care. All right. And the question is like, how long does alcohol stay in the body? All right. So in the breath, it will be about 12 to 24 hours, and in the hair, up to 90 days, and in the blood, up to 6 hours, in your urine, up to 12 to 72 hours, in the saliva, up to 12 to 24 hours. That's how. So that's why you find that there is that breathalyzer and other methods of testing how much alcohol concentration you have got with you. They don't test whether you've got alcohol, you took some alcohol or no. They're actually saying how much of content, concentration is there in your body. All right. So this is for different types of alcohol. They take different moments to stay in the body and even to kick in, right? So a person will feel the effects of alcohol in general after 15 to 45 minutes of drinking, but some veteran drinkers they take longer than that, and depending on the beer, of course, because a beer has a lower alcohol concentration compared to a liquor like tequila or rum. So if a person drinks one standard drink of liquor compared to one standard drink of beer, they will most likely feel the effect of the liquor faster, right? And that's how much it stays in the in the body. So this is one of the things that you now need. So there is the bloodstream, and then there is the body, and then there is that movement in between that you must also understand. So this information is courtesy of sandstonecare.com. It's a blog that gave me this information. It's not of my own making. All right. So we have got the concentration C1, which is here, the concentration of alcohol drug in the human body compartment. And then there is movement from the human body to the bloodstream, then also from the bloodstream back to the human body. All right. So, like I said at the beginning, they didn't explain to us why these dynamics are actually important. All right. And we've got the intercompartmental distribution rate, and then the excretion rate constant, and the first order rate constant. And so, this is when it is being discharged completely out and it's going out. And the volume of alcohol drug in both compartments, which is V, so it means V must be C1 plus C2 because these are the concentrations that we have, and alcohol drug dosage in both compartments. All right. So um, this is what they want to talk about. So one would expect that I've got two compartments, so it means that most likely we have got two differential equations that describe this system that we have got here. There is a lot of movement. There is movement from C1 to C2, there is movement from C2 to C1, and then there is excretion that you can see here. That's when it's leaving the body. All right. So I think that in our so far I haven't said really much of anything, but I was just looking at the way they introduced the paper to us, and I'm not happy. Personally, I'm not happy and saying, look, they could have said why are they studying this and what is different about their research from other people's research, and because it's all about novelty at the end of the day. So because there are so many papers that I've seen on blood alcohol concentration, and I would expect the results that they are going to get here to be the same as well with the results from those other people. All right. So we are going to continue now looking at the model itself. All right.